In example 4b, what we're doing is we're going to use the fundamental theorem of calculus to calculate coordinates. The way we do this is we're going to use the integral to work out the displacement. So the integral in green here is going to give us a change in x. Now, to be able to work out a coordinate, we need to know where we're starting. So the starting point is going to be based on starting at 0. So if we start at 0, the y value that we're calculating is going to be 2. So we have a starting coordinate of 0, 2. Now, if we think about it, if we integrate from 0 to x equals 0, that's going to give us 0 area. So we're starting with 0 displacement, so we're going to have this y coordinate of 2. So then to find g of 1, what we're going to do is we're going to start with the value 2 plus find the change in the g function, which is the area under the curve from 0 to 1. So this is what we have here. This is our integral here from 0 to 1. So then we calculate this integral. Okay, so I'm going to do this over here. This is equal to 2 plus, I'm going to use the antiderivative and the change in the antiderivative to work out the area under here. The antiderivative of this function is going to be arcsine. So we have arcsine of t. Okay, so arcsine of t from 0 to 1, and that's going to give us the displacement, which will give us the change in g, which then allows us to find the y coordinate. So the arcsine of 1 minus the arcsine of 0. So we end up with 2 plus arcsine of 1. Arcsine of 1 is going to give us 90 degrees. The arcsine of 0 is 0. So from 0 to t equals, or x equals 1, we have an area of 2 pi. So then our g of 1 is equal to 2 plus, so not 2 pi, but pi over 2. Okay, so then we have a coordinate at x is 1, y is 2 plus pi over 2.